Okay, so question number 2. I went ahead and drew an electron configuration chart from the previous take, and I didn't want to erase it, so I just left it. But in the first column, we have all of our s orbitals. They can hold 2 electrons. Second column is the p orbitals. They can hold 6 electrons. And third column is the d orbitals. They can hold 10 electrons, and this follows the Aufbau principle. So when we're making our ground state electron configuration, we would go ahead and follow this order. So if I had yttrium and it was neutral, it would have 39 electrons, right? So I'm going to go ahead and draw my ground state electron configuration according to the Aufbau principle. So 1s, 2s, then next is 2p, so that tells me that order. And when I add all of these up, so 3s, then 4s, 3p, then 3d10, 4p, 6, and 5s has 2, and then after 5s, let me move this over here. Actually, I'll move this over instead. And then, so that right there is 38 electrons, and then we do 4d, and he has 1 electron. That gives us the 39 electrons. But what we want in actuality is y plus. And y plus 1 has 38 electrons. But when we're going to make a positive ion, we go to remove an electron, we don't follow the Aufbau principles. We actually take away an electron from the highest quantum number. So here I have 5. So I'm going to go ahead and I'm actually going to take 1 away from here. And so this would be my electron configuration for y plus 1 right here with 38 electrons. So we took 1 away from here, this 5s orbital. So which orbital will z be added to? So if that z electron is added, y1 plus that z electron is just gonna, I guess that will become, just gonna become yttrium, neutral yttrium. I'm just gonna take off z. Oops. But this is understood that that's that 1 electron is getting added to it. It will become yttrium, which that has 39 electrons. And so if I'm gonna add an electron back into this electron configuration, it's gonna go and get added into this 5s orbital. So which orbital will that will z be added to, z electron? It will be added to the 5s orbital, because this is a yttrium plus 1, and now we're making it yttrium neutral, so we add an electron, and that electron will go to the 5s orbital. Okay, continuing from there. So if we draw the electron diagram, I had drawn it in a previous take, and I didn't want to erase it, but this is the basic setup that you would just know that you could draw easily. And the important part to know is that we're going to be adding electrons to it. So we actually need to go back here and follow the Aufbau principle and use this chart. But it's very similar to what is drawn on that chart above. We just have our orbitals, and we have This shows how many electrons each of them can hold, and it shows the order. So increasing, this is energy is increasing. So now the next step is to draw the electron diagram of yttrium atom after electron Z is added. So it's going to be after. So it's actually going to be, let me copy and paste this. So it's actually going to be something like this. So now I can go ahead and I can draw in all my electrons based off this electron, ground state electron configuration right here. So let's go ahead and put our electrons in. And try and go quickly. Okay, after 2p comes, let's see, 2p, then 3s. After 3s comes 4s actually. 4s, then 3p. Um, 3p, then 3d. And I have to get to 39. So 3d is full. Then I look, I'm like, okay, 4p is next. These get filled up. They would actually get filled up like this if we follow our rule, but I'm being lazy, so I'm not filling it up one at a time. Okay, so then that 5s gets filled, and so the final electron is going to be in that 4d orbital, but Z is actually, Z would have been this guy right here. I'm going to just circle him. He would have been filling up 5s, so that would have been Z. So even though you think this might be Z, based off of the Aufbau principle, Z is actually going to go in here, and he's going to want to fill up that 5s orbital. So we're going to circle him, and I'm going to say, okay, that's our Z electron. So continuing on, what are the quantum numbers? Oops, let me erase that. What are the quantum numbers for Z in this configuration? So be sure to label quantum numbers. So interestingly enough, when we look at Z, Z was actually added to the 5s orbital. So that tells us that its n value equals 5. That's that shell. And then I'm going to go ahead and draw, I'm going to draw a little chart next to this. So n equals 5. And we have 5s. I'm just going to do this because it helps me kind of remember the pattern. So when we have an s orbital, our L value equals 0. When we have a p orbital, our L value equals, 1, and then 2, and so on. Now the ML values. So for that s orbital, it's going to equal 0. For p, it's going to equal between -1 and 1. For d, and as you can see, that pattern is going to go ahead and it's going to continue. But I don't really need to worry about that too much because I'm going to stop right at the, I'm going to stop right at 5s. So it doesn't really matter. The rest of these don't really matter. It's just to illustrate a pattern. So I've got my n value, n equals 5. I've got my L equals 0. I've got my m sub L, which also equals 0. And then my m sub S can either be positive 1/2 or negative 1/2, depending on the spin of the electron. So we don't really know, but it could be either one of those values. Okay. Yeah, so we've got the principal quantum number check. That would be, I think it's azimuthal quantum number, if I remember. And we got the magnetic quantum number, m sub l, and then ms, which is the spin. So we have two choices. Positive 1/2 and negative 1/2, either or. Okay, continuing. How many valence electrons did the yttrium atom have after electron Z is added? So I think what's helpful here is we can look at the periodic table of elements, and we can see that, oops, where'd it go? So krypton would have 8 valence electrons. So when we're writing that electron configuration, we can use this shortened version and say krypton, and then we'll write the rest for D1. And this shortened way of writing it actually allows us to see how many valence electrons the yttrium has. So all of the ones past that noble gas krypton, they're going to be valence electrons. And so I can count 1, 2, 3. So that's going to be 3 valence electrons. And then how many core electrons does the yttrium atom have after the electron Z is added? Well, if all of krypton's, if all the electrons up to krypton are the core electrons, then we can see right there, sorry it's glitching, that would be 36 electrons. So since krypton equals 36 electrons, all of those are core electrons. Another way you can do it is we know that yttrium equals, actually I'm going to write it like this, because we know that yttrium plus that Z electron equals 39 electrons. So if that's the total, then I can simply subtract my valence electrons, and that will, sorry for the messy writing, that will get me 36 electrons. And that would be my core electrons. So you can either use the shortcut, the electron configuration shortcut, and you can look at that noble gas, or you can, I think that would be like the easiest way to do it. So yeah, I think that's a wrap. Cool.